All right, looking at number 3 now. A bottled water company claims that the average volume of water in its bottles is 500 milliliters. The population standard deviation, whoa, that's a weird one. We don't usually get this, is known to be sigma equals 10 milliliters. A quality control inspector randomly samples 40 bottles and finds a sample mean of 496 milliliters. At a significance level of 0.05, test whether the true mean volume is less than the claimed amount. So we just had a very unusual thing. We got the population standard deviation, and we're talking about means. We're actually only talking about one mean. So because we're only talking about one mean, this is going to be a one sample Z test. And again, it's a Z-test because they told us the population standard deviation, which is very unusual. When we go to do this in the calculator test that you're looking for is just the Z-test, which is going to be the very top when we go into the calculator test. Okay, so they've actually listed out nicely for us all of the data that we're going to need to enter. So what is the null and alternative hypothesis for this example? We're going to write down the null and alternative, where they're saying test whether the true mean volume is less than the claimed amount. So less than the claimed amount would mean that our mean is less than the 500, which is the claimed amount. That's our alternative hypothesis. So our null hypothesis, we can just flip that sign around and make it a greater than or equal to 500, or it's also okay to just have it be equal to, but this one has to be the less than. What is the test statistic? We're going to use the calculator to find this, but we know it's going to be a Z because it's a Z test. And we're also going to use the calculator to go find the p-value. So we're ready to do the calculator part. We're going to go ahead and hit the stat button, arrow over to the tests. And the Z test is the very first one. So we're going to select the Z test. Because we didn't enter a list of data, we're going to go arrow over to stats and hit enter. And then under the mu sub 0, we're going to enter the number that we have written in our null and alternative hypothesis. We're going to enter 500. Then where it says sigma, we're going to enter 10. And where it says that we want to enter the X bar, we're going to enter 496. And then the last thing we need to enter is the N. They told us that we're testing 40 bottles, so enter 40 there. For the next line, we go to the alternative hypothesis and we look for what sign we're using there. We're using the less than sign, so we want the middle choice. So we want the less than sign, and then go ahead and arrow down to calculate and hit enter. We do that, we get our Z value of negative 2.53 approximately, which then gives us a p-value of 0.0057. So we're comparing this z value, or sorry, this p-value to our alpha. So our alpha is about 5 pennies, and our p-value is less than 1 penny. We're at about half a penny going on here. So the p-value is much smaller than our alpha. So p-value is less than alpha. If the p-value is low, the null must go. So we're going to reject the null hypothesis. So in terms of what is our conclusion then for this problem, we're going to say that there is sufficient evidence at the 5% level to suggest, and then we always go back to the alternative hypothesis, that the true mean volume is less than the claimed amount, which was 500 milliliters. So again, because our p-value was smaller than our alpha, we reject the null hypothesis. So there is sufficient evidence at the alpha was 0.05, so the 5% level, to suggest that, and then we always come back up here, the true mean volume is less than 500 milliliters.